Kittywinks, I cannot stress enough to you how important functions is as a subtopic because it's the basis of so much we have to do, like trigonometry and calculus. We need to understand functions. You have to be comfortable with composite functions, inverse functions, translations, recognizing features of functions algebraically and graphically, and applying all of that to real life problems. But you can ignore the basics like the domain and the range and the proper notation. So I'm going to shrink myself and zoom up into this corner, but I am watching you carefully to make sure you're paying attention. So a function is a relation. But hang on a minute, what's a relation? Well, you know, relations like your brother or your sister or your aunt. No, okay. So a relation we're talking about is an ordered pairs, so like x and y. But there's a special type of relation, and that is a one-to-one. Hey, have you noticed I'm talking without moving my mouth? I'm just so clever. One-to-one. Yeah, I've been practicing my ventriloquism. Or many-to-one relation. Okay, so that's what we're talking about. What does that mean? Well, what it means is that for every x value, there's only one y value. Okay, just make sure you understand that. But I'm going to explain a little bit better. So let's imagine that we've got our pool of x values. Check that out. I'm so good at this. I can draw perfect little ellipses. So here's another one. Wow, that's so much fun. Now this is what we would call our range, because I'm going to make this all the little y values. Here we go, call them y. And just these are any sort of values you can imagine. Just put any old number to it. And here's our domain. And this, of course, is our x values. We'll just shove a few in there. And this is our input into our function. And this is our output. So, and that's input's going to go into there by the rules of the function. Okay, so the function is going to create a rule and do something to it. Now, what I mean by one-to-one is that each x value has a y output value. Okay, so that's one-to-one. Now, many-to-one, well, that's super interesting because each x value only has one y value, but the two x values might have the same y value. You see, two different ones. So how does that work? Well, let's consider a couple of examples. Let's think about y is equal to 2x plus 2. Now that's a straight line. So you know, with a straight line, you've only got like one y value for each x value. See, each one is different. So that's a one-to-one. That one there. Now, what about an example of a many-to-one? Well, what about this one? Y is equal to x squared plus 2. Do you see where I'm headed here? Because what about if I put in -2 into that equation? What if I say x is equal to -2? If x is equal to -2, then x squared is 4 plus 2 is equal to 6. Well, what if I put in x is equal to 2? Well, 2 squared is 4 plus 2 is 6. Y is equal to 6. You see there? So in that situation, I've got a many-to-one in this case. Now, if you look at the graph of that, it's not so difficult to understand because that's a parabola, right? So if you think about a parabola, here you can find, like, so for example, at this x value and this x value, we have the same y value, right? Okay. Think about this example. See, I'm throwing a ball. This is me throwing a ball. The ball is going to start from where I'm standing. It's going to go up, and then it's going to go down and fall down. Now, so if I look at the relation, the function, you know, distance is a function of height. At any particular distance, there's only one height. Now, you can't have two different heights at the same time, and you know the ball can't be at two different heights at the same time. Well, unless you're in some kind of weird dimension. So that's what I mean. You can't have more than one y value, but you could have this x value could have the same height because the ball's going up and back down again. Okay, so, but I've got a much more interesting way to tell you, and you'll never forget. Now here's a fine looking gentleman who meets a lovely lady, and after a while they decide, what, we could become a pretty ordered pair. I think we could function very well. And this man, happens to be called Mr. Y, says to Mrs. X, yeah, I think we could become a pretty good ordered pair, and I think, yeah, we'd function pretty well. But of course we all know that Mrs. X, being the lady in this relationship, is the independent one, and he is very dependent. He probably won't admit it, but that's the way it is. So they carry on and they have a lovely one-to-one relationship, and they function well. But just imagine Mr. Y is actually Muslim, and he moves to Malaysia where he is allowed to have more than one wife. Yes, he figures he can afford to have another wife. So that's what. Oh, she's huge. She better shrink a bit, otherwise he's not going to be interested in another wife. So he says, yeah, okay. So I'm gonna take another wife, and her name is also X. I would just call her X1. So now here we have a many-to-one relation, and that also is a function. Many-to-one, well, actually it's really only two. Maybe he needs another one as well. Let me see. Here we go. Another lady coming in. Okay, 3 ladies, also X. Now you see. So you see, they work well together, and it's perfectly legal in the functional society. That's perfectly legal, but you can't have it the other way around. Actually, I think it's pretty unfair. I think us ladies should be able to have more than one man. What do you reckon? You can have a relation where the X value can have more than one Y value. I mean, check it out. I'm going to create a circle. Oh, wow, that's a fantastic circle. See how good I am at circles? Now, that relation is, let me see, that's x squared plus y squared is equal to, let's say 2. Not quite accurate, but that'll do. So that's a relation where you've got, see, this x value has actually got 2 y values. See that? But the question is it a function? Well, no, it's not. And here's how you can do the ultimate test of whether it's a function or not. You can draw a straight line like that, any sort of straight line, anywhere in that graph. So let me draw another one here. Oh, look how straight that line is. And then another one. Whoa, stay still. And then another one here. Look, see. But in all of those, you can tell that I have 2 y values for every x. So it is not a function. It is a relation. In fact, it's a beautiful circle, but it's not a function. Now, how about these fancy looking graphs? Okay, what about this one here? This is y is equal to absolute value of x. This one down here is pretty cool. Y is equal to 1 over x. And what about this fancy one here? Y squared is equal to x plus 2. Whoa, nearly fooled you. It's not plus. Yeah, that's a tricky one. Y is equal to x. Y squared is equal to x minus 2. Now, do you think which one of these do you think is a function? Well, let's just do the straight line test. That's like the easiest thing to do. So we'll just draw a line. Okay, it doesn't matter how many lines are drawn on this one. It's not gonna coincide with anything drastic, is it? Let me see. Draw one here. That was so straight. Yeah. So it doesn't matter how many draw. I'm only going to get one y value. And here, well, yes, it's the same. This is also a function. There's a beautiful asymptote there. It's not touching anything there, but it's still a function. But here we go. What about this one here? This is this one here. We'll draw a straight line here. and all of a sudden I've got two y values for this same x value, see? So that is not a function. There you go. So straight line test is your test to see if a graph is actually a graph of a function. There you go. In the world of functions, that has its own language, its own special written notation. By now you should be pretty familiar with it, so it shouldn't be too hard to just quickly revise this. In a function where y is equal to 2x plus 8, you may see it written by this. The function of x is equal to 2x plus 8. Or you may always also see this. The function of x such that x becomes 2x plus 8. So these two are just function notation, but it means the same thing as this. Now, domains and ranges also have their own special language. So a domain is basically all the possible, or let's say permissible or allowed values of x. Okay, we can't have anything illegal here, all right? It's got to be all correct. So you might see, if all the x's are allowed, you will see something like this. You'll see that x is an element of all real numbers. So what do I mean when I talk about an x value that's not allowed, that's not permissible, it's going to cause problems to the universe? Well, let me explain. What if f of x was equal to 1 over x? X cannot equal 0. That would just be terrible. X cannot equal 0. That is totally undefined. You can't have 0 in the denominator. It's not allowed. We can't divide by 0 in this dimension. If we did, we'd end up in a black hole. So it just can't be done. Avoid it, or just don't allow it. So for example, if you have an equation where you have y is equal to 3 over 2 minus x, well then you know that x cannot equal 2. So your domain is going to be x not equal to 2. It can be anything else. So just remember that. Now range is all the y values. Okay, and similarly there are certain things that are not allowed. So you'll still see the range written as y is not equal to 0, or maybe you see it as y is greater than 2, that sort of thing. Or even the same thing, y is an element of real numbers. That's how you might see it. But again, don't do anything dangerous. Like, what if I have this equation where y is equal to, or actually we should really stick to the function notation. Oops, sorry. What if you have this equation where f of x is equal to 2x squared? Now, what can you tell me about that? Well, I can tell you that the range cannot be a negative number. Why? Because of this. It doesn't matter if x could be negative. You have negative 2 squared. That's going to be equal to 4. Whatever happens, this baby here, the range cannot be a negative number. Therefore, y has to be greater than or equal to 0. Imagine you were looking at the relationship between age of a kangaroo and its height. So here he is, a very small little Joey, and he grows up and he becomes this big boomer. Now, you see, you can't have a negative height in a kangaroo, can you? Unless you suck him up in a vacuum or something, or unless you call him Schroeder's kangaroo. And that's pretty funny. Anyway, I think you get the point. So that's the end of the very brief introduction. The next thing would be to do composite functions and inverses. So that'll be the next thing. By the way, my spider just got new glasses, which is just ridiculous because they look stupid on him. Okay, now the next thing you got to do is go away and practice some exam questions. So toodle pops.